right, in this lesson, we're going to be reviewing the study guide for Summative 2. Hopefully you had a chance to go ahead and look at that study guide over the weekend. If you have not, pause your video and try the problems in the packet. These are the topics that we're going to be covering: relations and functions, linear functions, arithmetic sequences, scatter plots and line of best fit, and then analyzing lines of fit by talking about residuals and causation. Okay, so our first question: a mother decided to track her baby's growth over a period of months on the graph below. Use the graph to answer the following questions. So in the first one, it says, is the chart above a function? Justify your answer. So they give us this graph, and we're looking at all of our x values. Does every x value have its own y value? In this case, yes. There are not any x's that are doubled up. So we could say yes, because each x has its own y. I'm going to go ahead and type that here. You could also say there are no repeating x's. X values. So a couple different things that you could say for that question there. All of them show why it is a function. Okay, and this makes sense in this problem because we're talking about one baby's length. As they grow, they can't be two different lengths at the same age. Okay, for number 2, write the explicit rule for the nth term of this sequence. So I gave you over here, this is the explicit rule, the formula for that. So what we're going to do is we want the nth term. So anytime we see the n, we can go ahead and keep it in our sequence. Okay, so we're going to start with writing a sub n equals, a sub 1 stands for our first term in our sequence. So if we look at our sequence, it starts with a 4. Plus n minus 1, we're going to go ahead and keep that. And d stands for common difference. So what is happening every single time? Well, in between each one of these, we are adding 5. So our common difference, in this case, is 5. So we're going to multiply this whole entire thing by 5. Okay, now the second one says, what is the 10th term in the sequence? So we're going to take the equation we just wrote, and this time we're going to solve for a sub 10, the 10th term. So every time I see an n, I'm replacing it with 10. All right, so now we can go ahead and solve these. So according to order of operations, I have to do 10 minus 1 first. So I have 4 plus 10 minus 1 is 9, and that's going to be multiplied by 5. Well, then we have to do multiplication before we can add. So 9 times 5 is 45. And when you add 4 to that, our a sub 10 value, or our 10th value in the sequence, is going to be 49. Okay, remember the left-hand side is just the name of the function. So in this case, it's a sub n. This one's a sub 10, meaning the 10th term in our sequence. Okay, this one asks for the recursive rule. So I've given you the recursive rule. So just remember, recursives have 2 lines. Sometimes they write them side by side, but the first line, a sub 1, stands for what is the first term in the sequence. So in our sequence, our first term is 3. Okay, and then the second line, it doesn't tell us any individual term that we're finding, so we're going to keep it as a sub n. All right. This piece right here, a sub n minus 1, that represents the term before the one that we want. So we're going to keep that all in one piece. And then we're going to add our common difference, or our d, to it. So in this one, what is happening every single time? Well, every time they're adding 2. So we're going to add 2 to it. Now, if you had a negative difference, if you were subtracting every time, this would be a negative sign, but in this case, our equation is going to have a positive 2. And so in order to be recursive, we have to make sure we have both of these lines. Which of the following terms is included in this sequence? And this is the same sequence we talked about earlier: 9, 14, 19, and 24. So the common difference that we found out before was we were increasing by what each time? We were increasing by 5. So what I would do is I would go and keep on adding 5 every time. So 24 plus 5 will give me 29. Well, I see that in my list, so that's definitely one of them. 29 plus 5 will give me 34. So that's one of them. Okay, 34 plus 5 will give me 39. Nope, no 39. All right, if I add another 5, I would get 44. No 44 there. If I add another 5, I get 49. And if I add another 5, I get 54. Okay, and so we've gone above what we have here. So those 3 would be the 3 that would be part of our sequence. I can kind of see a pattern, 9, 4, 9, 4, 9, 4 each time. And the 2 that we did not choose do not have 9s or 4s in their last digit. All right, describe the function notation of f of 5 equals negative 10. What is the output? What is the input? And what is the name? So this one, we have the input is easier to start with. That would be our x value. So input, and this one would be 5 in this problem. That's what we're putting into our function. The output is the result of what's coming out. In this case, the answer that's coming out is our negative 10. Now the name of the function is our f, or f of x. So it's important to know what those pieces are of a function. Okay, these ones are evaluating functions. So for these ones, you should be substituting whatever the given value is in for x. So in this one, find f of negative 5. We're going to take our function and we're going to replace the x's with negative 5. All right, according to order of operations, I have to multiply before I can subtract. So negative 2 times negative 5 gives me a positive 10. Minus 5. So my f of negative 5 would really equal 5. Okay, I'm going to change colors here so we can see the second one. This is f of 1/2. So I'm doing the same thing. I'm going to substitute every time I see an x, I'm going to replace it with 1/2. All right, 1/2 of negative 2, well, that's negative 1. And if I take away 5, f of 1/2 should be equal to negative 6. Okay, make sure that's 6. Now be careful with part C. Let me erase that real quick. C is very different. Okay, this one put a star next to. It says find x when f of x equals 20. So that does not mean substitute 20 in for x. Okay, it's not written like the other two. This one means the left side, this part of the equation has to be 20. So we're going to say 20 equals negative 2x minus 5. And we're solving for x. So do you see how the 20 went in a different location in this one than the other two before it? So if I go ahead and I solve for x, I'm going to add 5 to both sides. So I get 25 equals negative 2x. And if I divide both sides by negative 2, I get x equals negative 12.5. And that would be my final answer for that one. Okay, please make sure that on your test you're showing work whenever possible. Okay, in this one, the cost to manufacture X pairs of hats can be represented by the function C of X. If it costs $384 to manufacture 32 hats, which of the following is true? So we know our function is C of X. We have to decide 384 and 32, which one is the input and which one is the output. In this case, when you input 32 hats, the output would be $384. So looking at our answers, which one has those in the correct location? So if you look here, the one that has in the correct location is A. 32 is our input, 34 is our output. Sorry, 384 is our output. All right, does the input-output table below represent a function? What do you think? For this one, it does not represent a function. And that's because if you look at your x's or your inputs, there are two of them that are the same. So the twos match. So for this one, you could say, no, this does not represent a function. Because there are two repeating x values. Okay, is this relation a function? Okay, and well, it tells us that it's going to be a function. The next output is 14. What are three possible inputs so that way the relation remains a function? Well, remember, in order to be a function, we can't have any repeating x's. So for this one, this is one where you could have multiple answers. The only answers we cannot have in for this spot right here where the question mark is -2, 5, or -4. So we can have anything except -2, 5, and -4. So if I wanted to come up with numbers, if I want to put down three possible answers, I could say 0, I could say 6, and I could say -10. All three of those could go in that spot and still make this a function. All right, for this one, identify the domain and range of the relation. Is the relation a function? Okay, so for this one, for our domain, remember we are listing our domain from least to greatest, okay? And they are already in order for us. So our domain are all of our x's or all of our inputs. Okay, so let me go ahead and type this. I'm going to say 0, 1, 2, 3. All right, for my range are all my y's or all of my outputs. All right, I have -2, 1, 2, and 4. And remember, we do not have to show any repeats, although there are 2 zeros and there are 2 ones. We do not have to show them when we're listing our domains. Is this a function? No, it is not. There are repeating x's or x values. Okay, in this case, our repeating x is the 0, because 0 goes to -2 and 0 also goes to 1. So that is what makes this not a function. All right, so for this table, we need to continue this. Sometimes they're going to ask us for the sequence. Sometimes they ask us for the recursive formula. I've given you the recursive formula again here. Now notice when they write it in recursive formula, they just put the f of 1 at the end. It doesn't matter. You can put it in the beginning or at the end. Either one is fine. So just keep up with what they said. I'm going to go ahead and put it at the end. Okay. So if we are typing this function, all right, it might be a little big at first. Let's see if I can make it a little smaller. Okay. We are starting with f of n. F of n equals, now where it says f of n minus 1, that's the same thing as this a n minus 1. So that is a part of the equation. So we want to keep that. That just represents the term before the one that we're looking for. And then if you look, we have our common difference. So we have to decide what is happening between each one of these. Okay, so to get from 0 to 4.5, we're adding 4.5. And that is the common difference between each one. We are adding 4.5. So that would be what our second line would look like. Now they want us to also put down what the first line would be. So what is the first, the first term in our sequence? Well, if we look over here, our first term is 0. So I'm going to say f of 1 equals 0. So I have my actual formula, and then I have my first term in the sequence. Okay, let's go ahead and jump down to this one and do that same thing, and then we'll come back to number 2. So in this one, again, we're going to start with f of n equals, and then I could have the f of n minus 1, which is the term before. What is the common difference in this one? Well, to get from 12 to 19, I have to add 7. Okay, so if you're adding, you're going to put a plus sign there. If you're subtracting, you're going to subtract. All right, what is the first term in our sequence? Well, the first term in our sequence is 12. So I have to list that as part of it. And like I said, the order does not matter as long as you have both pieces for recursive. Now, for the second one, this one gives us the equation and we have to write the sequence. Well, looking at this, I can tell that my first term of the sequence is 68. So I'm going to start there. All right, 68. And then by looking at my formula, it says I'm going to take the term before and I'm going to subtract 11. So if my term before was 68 and I'm going to take away 11, so that's going to be 57. And then if I take the term before and subtract 11, I'm going to get 46. And then I'm going to get 35. Then I'm going to get 24 and so on. Okay, so I can write my sequence based on the information they give us, our first term and then whatever our common difference is. All right, in this one, it says estimate the correlation coefficient that most accurately represents the data. So they give us this data here. If I were to take a line and I were to draw a line of best fit, it would probably look something like that, where it goes through some of my points, but not all of them, but generally close. So looking at this, whenever we have, we're talking about line of best fit, you have to think of the spectrum. All right, so it goes from 0 in the middle, +1, and -1. So 0 represents no correlation, none at all. So that means that these dots are scattered all over the place. You can't even tell if it's increasing or decreasing. That is not the case in ours. We can tell that it's definitely positive because it's increasing from left to right. Okay, we can also eliminate these two because these are negative and this is a positive slope, not a negative slope. Okay, so now we have to decide. One is a strong correlation. Okay, so where would 0.98 be? Well, 0.98 would be really, really close, like very, very strong. 0.65 would be like, maybe right here would be 0.65. All right, so to decide which one it is, you need to look at your dots. How close are they to your line? This one is almost exactly on the line. This one, they're scattered out a little bit. So I would say that this would represent a 0.65 correlation coefficient. Okay, 0.98, like I said, is very, very close to 1. I would see these dots and they would almost all fit exactly on that line. And this one, they're spread out a little bit more. Okay. In this one, each day at a bakery, Jack bakes cakes and helps at the counter. The data below shows the hours Jack spends at the counter as a function of cakes he bakes. Okay, so we have our X value. Whoops, I didn't mean that to be X, lines there. We have X and we have our Y. Okay, they tell us the line of best fit. So they say this is our equation for the line of best fit. We have to find the residuals. So if you remember, to find residuals, you take your actual Y's minus your predicted Y's. Okay, and we're going to subtract these. All right, so the first thing that we need to do is we need to figure out what our predicted values would be. Okay, so what I'm going to do is I'm going to show you on my calculator. You can use your Desmos calculator if you would like. To find our predicted values, we are going to substitute all of our X values into this equation. So I'm going to start out by doing negative 0.45. My first X value is 2. And then I have to add 469 to it because that's part of this equation here. I just substituted this 2 in. Okay, and I got 379. Remember that these are our X's and these are our Y's. So when I put that in, again, I got 369. So that is my predicted value. I'm not looking at this column at all. Now I'm going to do the same thing with 3, 5, 6, and 7. So if I get my calculator, I'm going to cheat a little bit. I'm going to put it back up there, and I'm going to change my X value. Instead of being 2, I'm going to change it to 3. And I get 334. Whoops, I need to change that to a 7. So that's a 7. And let's make sure 334. All right, we're going to do that for all of our values, all of our x values. I did this already ahead of time, so I end up with 289, 199, and 154. Okay, so now, like we said, we have to take our actual y values, the ones that are under the time column, and subtract our predicted values that we had. So if I take 3.5 and I take away 3.79, that means I'm under by 0.29. Okay, 4 minus 3.34, I'm going to be over by 0.66. Okay, and then you do the same thing. So our actual minus our predicted. This one's under by 0.89. Actual minus predicted. Actual minus predicted. Okay, and that's how we get our residual values. Now, the second part says determine if the line is a good fit for this data and explain your reasoning. So what I decided to do, even though they didn't give it to you, I put these values on a residual plot. Remember, the residual plot only has quadrant 1 and 4. And for every x value, I plotted the residuals, whether they were over or under our actuals. So it put the first 3 on there for me. I need to put the last 2, the negative 0.49 and the 4.6 on there because it didn't put it on there for some reason. So when x is 6, we're going to go down almost half. It's right about there. And then we're going to look at our last one is 0.46. So that one is over by almost a half. So like right there. So it's asking if this is a good fit. There are 2 questions you need to ask yourself. Are there some dots that are above and are there some dots that are below the axis? In this case, yes, we have a good spread. Some are above, some are below. And I'm sure if we continued this data out, we'd probably be able to see a little bit better. And then the second question are these dots close to the axis? Okay, if they were way out like by 4 and 5 or negative 4 and 5, I would say this would not be a good fit. But because most of these dots are right at our axis or really close to it, I would say yes, this would be a good fit. Right? And they are close to 0 or close to the x-axis. All right, for number 13, this one on your test, you're able to double click and graph just like you did on your study guide. So the first one, they want us to graph the data on the grid below. So they do not give us any value, so we have to decide what we're going to count by. Our x's represents our GPA down the bottom here. And I can see I go up to 4. So I'm going to spread out my values a little bit. So I'm going to count every 4. So each one will represent 0.25. So 0.25, 0.5, 0.75, this would be 1. 1, 2, 3, 4, this would be 2. This would be 3. And this would be 4. Okay, and the reason I did that is I want to spread out my data as much as possible. If not, it'll be all scrunched in one little corner, and then it's going to be hard to see what our data looks like. Okay, for our Y's, this is our SAT. So this was the GPA down here. And this is going to be the SATs over here. This one, we're going from 940 all the way up to 1380. So what I did was I counted every single one to be 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this could be 1,000. And 1, 2, 3, 4, 5. I'll write every other one. 500. 1, 2, 3, 4, 5. So this would be 1,500. 16, 17, 18, 19. This would be 2,000 up here. So we go a little above and a little below what we need. So let's go ahead and graph these. All right, so when the GPA is 2, our SAT score was 940. So I'm going to try to estimate the best I can. So there's 5, 6, 7, 8, 940 would be a little bit above, like right there. All right, 2.5 was 330. 2.5, 1, 2, 3, 30. Okay, 2.8 would give us 990. Well, this is 275, so 2.8 would be a little bit more than that. And we go up to 990, which is almost 1,000. Okay, I'm trying to get as close as I can for these. 3 was 1020. So 3 is going to be above 1,000. This is 1,100, so it's going to be like right there. All right, 3.3 and 1050. It's going to be up there too. 3.5, 1,100. Okay, 3.8. It's going to be 1,300. So that would be 12. This will be 13. Right on that. And then 4 is 1,380. It's going to be up there. So in this graph, we can kind of see this one over here is way kind of out of line. Did I even do that one right? Let's see. That was 2.5 was 930. Whoops, that one should be up here. 930 should be like right there. So let's go ahead and get rid of this random point down here. It doesn't fit our data. So we can kind of see the trend that it is increasing from left to right. We could graph our line of best fit of wherever we think it would be. I think it would be roughly something like that. Okay. This one says find the equation for the line of best fit. So for this part of your problem, you would like to use your Desmos calculator. So I'm going to go ahead and show you what that looks like. I've already done it ahead of time. Okay, so it looks like this. You can see I put all of my X values, my GPAs in my X column, all the SAT scores in my Y column. You can kind of see the data here. I did have to change my window. So this is what I changed my window to. And actually it changed a little bit. I originally did from 0 to 5, and then I did from 900 to 1,400. But I did zoom out. When you zoom in and out, that does change your window a little bit in here. Okay, but again, just change them to above and below your X and your Y values. So to figure out our line of best fit, we have to come down here and we're going to type in Y1 and then the squiggly line, MX1 plus B. Okay, if you don't put that plus B part, it's not going to give you all of the information that we need. So I can see from this, I can see my R value, which we're going to need for part C, and I can see my M and my B. Now, because they are decimals, I am going to round. I'm going to call this 222, and I'm going to call this one 399. So I just rounded to the nearest whole number. So when we go back to our slide right here, it asks for the line of best fit. So we can say Y equals 222X plus 399. Okay, that is our line of best fit. Okay. And for part C I believe is on the next page. It says, what is the correlation coefficient? So if you look at the graphing thing that we just did, our R value is 0.8981. Okay. So let's go ahead and type that in there. R equals 0.8981. Okay. Now remember our scale. Anything that's really close to 1 is going to be a strong positive. If it's close to 0, it has no correlation. If it is close to -1, it has a strong negative correlation. Now this one, although it's like 0.89, it's not super strong. It's not super close to 1. So I would say it has a somewhat strong positive correlation. Okay, it's not the strongest, but it's not weak either. So it's kind of in the middle. And then this one says Stephanie has a SAT score of 1,200. Use the line of best fit to help make a prediction. So looking back at our information here, if her SAT score is our Y value, 1200 would be, if it was on this graph, would be here between 1100 and 1300. So this is an example of interpolation. It's inside our data. Extrapolation would be if it was outside. So they're asking us to interpolate this by figuring out what 1200 would be. Again, 1200 is our Y. So I'm going to use the equation that we came up with before. Y equals 222x plus 399. All right. Now we said the 1200 is our Y value. So when you solve this, you need to substitute the 1200 in for the Y, not for the X. Okay, let's go ahead and solve this. So if I take 1200 minus 399, okay, I get 801. So I'm going to have 801 equals 222x. My last step is to divide both sides by 222. So if I divide by 222, I get a 3.61 roughly. So that represents the GPA that she would have if she had a 1200 on her SATs. Okay, so just important, make sure that you are knowing, does that 1200 go in for X or does it go in for Y? And I knew it went for Y because I looked back at my table and saw the SAT represented my Y values. Okay. In order to receive credit for today's lesson, since you are working on your study guide independently, you need to answer the discussion question that's on Schoology. So please go on there. It is in today's folder. Answer the question, and then I will mark you present. If you have any questions or you need help or would like to see some more examples, I am available in the virtual classroom. So just log on in and I'll help you.